Hey, it's Alan. So, for my topic, I decided to choose NBA player performance, and I took my data from the 2017-2018 season, and the data was just on NBA.com. It's pretty easy to find. And I chose the top 50 players because I had three wide variables, and that would yield 150 values. Why I chose this topic? I chose this topic because I'm interested in basketball, and just recently I got interested in watching the NBA and paying attention to the players and their statistics, and I got into a NBA fantasy team where I'm playing with all my friends. But yeah, that's just partly the reason why, and I thought that if I chose something I was interested in, then I'd be interested in the project and I would work hard on it. I'll talk about my variables instead first. So for my variables, for my independent variable, I chose average minutes played per game, and for my dependent variables, I chose three Y values. Average points made per game, average assists made per game, and average steals made per game. So on to my hypothesis. So my hypothesis was a player that has played more minutes will have more points, assists, and steals. I thought that made sense because you have more time on the court would mean you have more opportunities on the court to do these points, assists, and steals, which having more opportunities would actually yield more of these points, assists, and steals, and that's just what I thought. So now I'm going to go on to my one variable analysis. So a lot of these values, just the explanations are repetitive, so I'm just going to choose average minutes played per game for specific values, but then I'm going to talk about standard deviation for the assists and steals. So for the average points made per game, the mean being average minutes, yes. Average minutes played per game, the mean being 33.4, just means that among the top 50 players, the average minutes that were played in a game was 33.4 minutes. Self-explanatory. The median was 33.5. You can see that right here on the box and whisker plot. You can see that right, 33.5, and that's where the median is. And the median is just taking the two middle positions, the two players that I guess you would call the most the middle players among the top 50, which was the 25th and 26th position, and I just took the average of their minutes played per game, and it turned out to be 33.5 minutes per game. Onto the mode now. The mode being 36.4 was partly illustrated here, but I'll explain this. It shows that there's a higher range of values, and the more players got this range of values than the range of values between around 35.71 and 37.06, and more got between 31.43 and 33.57. But that doesn't necessarily mean that a certain player got this, they all got that value for and a bunch of them got that. I just had 36.4 as my mode because this value was actually shared by just that exact value was shared by more players than any others, and it was shared by 3. But here you can see on the histogram that even though the mode might be 36.4 and you expect this to be way higher, it seems that more players had minutes within the range of these two values. The standard deviation for the average minutes played per game is 2.4, which just tells us that it's pretty tight together because it's all about proportionality, and since there's pretty high value for the average minutes played per game, and then a particular player would have 2.4 minutes on average more or less played than that average, that's just the standard deviation means, and by proportionality, since that's not very much of that. You would if there were two players and one played 2.4 minutes more than the other one, you wouldn't say that their times were very far apart because they played very similar overall time. It wasn't a huge difference. And the range being 10.2 just tells us that the player with the lowest average minutes played per game among the top 50 and the player with the highest average minutes played per game, that's just the difference between the two, 10.2 minutes. All right, so let's skip that. But I'll talk about the standard deviation for the average assists and steals made per game. So the best way I can explain it is that when you go back to minutes, the standard deviation was 2.4, was a very, like, if you put this in a fraction, that'd be a very small number compared to what the mean was, which means that if players were just around like 2.4 above or below this, then they wouldn't be seen as like that different from the other players. But then if you go down to assists and steals, 0.5 and 2.2 would make a huge difference on the means, because if someone, just everybody was scoring around or making around 1.1 steals per game, and then somebody just had like 0.5 more, that would actually be like a huge difference. That'd be the same, like, use ratio ideas. That'd be the same as like someone just having, like, everybody's making 11 steals per game, and then somebody just gets 16 steals. Like, that's a decent amount more, and if that's a standard deviation, that shows that that is shared by a lot of the players, which means that in reality, it might seem like all of the values are close together, but they are actually quite separate and not very close together. And it's the same with the assists. 2.2 is more than half of what 4.2 is. So just keep switching. So just to explain, if you were like multiplying these by 10, if everybody was getting around 42 assists per game, and then just somebody came out and had 22 plus 42 is 64. If somebody just had 64 assists per game, that person would be like, you would not think that they are very close together if you would have many players that are having averages of 64 when the average, like the line, would be at 4.2, and you had players varying from like that many points compared to what the actual mean is. That just illustrates how close together and how spread out the values are for these two, which can be explained specifically for these assists and steals, because it would make sense that assists and steals would position wise, point guards and forwards would be having more assists and steals than a center, who would not be getting the assists and steals because they're just more like grabbing the ball and posting up. But like, they all players make relatively similar points. That's illustrated here, is they're all pretty close together. But this also, like, I can explain, but it also explains that the point guards and the forwards are going to be getting more assists and steals, and because among the top 50 there wasn't a specification of which position they had to play, so they're going to be all different types of positions. That's why the steals and the assists are so spread apart. Alright, that's that for one variable analysis. Now I'll go into two variable analysis. So for these I have scatter plots for all of them. I'll just go through them, just kind of look at them and explain them. So here you can see on the scatter plot, you can see some of them there is some correlation. You can see how they're like fairly close to the line, and that as it goes up, as the x value increases, the y values are increasing. So there definitely is some correlation here. And if we go down here to the r value, we can see that that is correct, as the r is 0.6134, which is a positive moderate strength correlation. And this supports the hypothesis that as you play more minutes, you will get more points per game, and that is shown here. Although it's not completely 100%, like that's the only thing that would affect the amount of points you make per game. There would be other variables that would affect, like such as the team you play on. But it would seem that the minutes does have a pretty strong correlation. Like, that would be one of the main variables that would determine the amount of points you make per game. Because if you don't have any, like if you play like 1 minute, you'll only be able to make like 1 point. So it makes sense. On to the second scatter plot I have here, which is the assists and average minutes played per game. You can see that compared to the other scatter plot, these are even less. There's even less correlation, and that's supported. You can see down right here. 0.32 is the R value, which indicates a positive correlation, which, yes, there is a positive correlation here. As we do move right on the X, you can see that the values are increasing somewhat. So you can say that there is a positive correlation, although it is not very strong. You'd say that that is a weak positive correlation. And that would make sense, like as I said before, there would be other variables that would affect the assists you make per game, such as the chemistry that you have with players, because this assist takes two people. Like if someone else scores and you pass to them, you get an assist off that. So that's how you get an assist. It requires one other person to be like a variable in this. So if you like have bad chemistry with the people, or like you're not going to be like passing them as much, and you know that, then you're not going to be getting as much assists, which will affect the values that it yields. Although there is definitely positive correlation, because I mean, if you had very low minutes, like if you only had 1 minute played, then you would be able to make very minimal assists. You probably wouldn't be able to make any. So that just also shows the positive correlation between the two variables. Now on to the last one, which is average steals per game and average minutes played per game. We can see that it's a stronger correlation than with the assists, but it's less than points. And that would make sense because steals are more self-centered. Like if you want to make a steal, you don't need like another person to go along with you. It's you that has to make the action. The only variable that would, or like the other person coming in, would be the person that you're stealing it from. So like a variable that could change this would be like their level of goodness or the chemistry out of the team. That would affect, like if they had better chemistry or they were just a better player, then you would make less steals because you wouldn't be able to steal the ball as much as they'd be a good player. So that could be other variables that could affect it. But like with the other ones, if you had 0 time, you wouldn't be able to make very many steals. So once again, there is a positive correlation between the minutes and steals, and it is about moderate strength. Regarding outliers, for points, there were not too many. There was one outlier, and that's just James Harden, because he's just really good player and he's often known as getting like a lot of points in a game. So that's just his outlier right there. But for the other two, there were multiple outliers, and these outliers are, I can explain them in a sense that every single one of these, like none of them are centers. The centers are all down here or down here. All of these players up here are point guards or forwards, or people who will be making more assists and steals on average per game. And that's just their position. But also these are just like one of the best like players. Like that's James Harden, that's LeBron James, that's Russell Westbrook. 3 names that are easily recognizable if you know much about basketball, and you know that they are extremely good players, and it makes sense that they have high values up here, and also they are point guards and forwards, which would also support this idea. Overall, my conclusion was correct. As a player did play more minutes, they did receive more steals, points, and assists, although just to elaborate a little bit on it, there are many other variables along with minutes played that do have correlation and can affect these values, such as the opponent and their performance level, or your team chemistry. Those are just 2 examples of other variables that might carry a lot of weight along with the average minutes played per game. But average minutes played per game is one of the definitive backbone variables that are needed if you want to yield any results with the other Y values. So that's my presentation, and I hope you made sense, and I hope you guys enjoyed.